Okay, for lesson 8.2.2, it is only two-sided, so you don't have to fold it in the middle if you don't want to, but I'm going to fold it in half just so it's a little bit easier to kind of talk to you about it, okay? All right, we're still talking about ratios of similarity, and we're still going to investigate the idea of scale factor versus area scale, all right? Alice has a 4-inch by 5-inch photo of your school's championship girls ice hockey team. Yeah, we don't have one. Okay, to celebrate their recent victory, your principal wants Alice to enlarge her photo for a display case near the main office. Sounds about right. When Alice went to the print shop, she was confronted with many choices of sizes: 7 by 9, 8 by 10, 12 by 16. She's afraid that if she picks the wrong size, part of the photo will be cut off. What size should Alice pick and why? So we want something that is similar. So remember, similar, you enlarge the size by a specific number. So enlarge the size by the same thing. You don't add, so you cannot add to the size. You want to multiply. So the only one that makes sense would be 8 by 10, because if you double the 4, you get 8. Double the 5, you get 10. The other ones don't multiply very well, especially the fact that you cannot multiply the same number to both sides and get the same results. So Alice should pick 8 by 10. It doubles each side. All right, what's under? All right. The cost of the photo paper to print Alice's 4 by 5 picture is 45 cents. Yes, printing pictures is pretty cheap. Assuming that the cost per square inch of photo remains the same, how much should it cost to print an enlarged photo? All right. So we could go ahead and figure out the area of the small picture versus the big picture, or if you remember, it doubled, right? So what we learned yesterday from our lesson is that if it doubles, the scale factor is 1 to 2. So the area must be 1 to 4 because you squared both of them. So 1 to 4. If the small one costs me 45 cents, because remember, when we're printing, it is an area we're printing. We're not just printing sides. That's what we must compare the area ratio here. So what's the cost going to be for the bigger picture? Cross multiply, and the bigger picture is going to cost us $1.80, right? $1.80. Okay. Unbeknownst to her, the vice principal also went out and ordered an enlargement of Alice's photo. However, the photo paper for his enlargement costs $7.20. Oh, this is kind of big. What are the dimensions of his photo? Okay, well, let's see. Let's take our original and compare to his enlargement. All right. And again, if you don't remember how to do this, you don't know how to you don't remember how to compare decimals. Move your decimals and then you can reduce. So if I move the decimal twice, I get 45 over 720. Now it's a lot easier to reduce. You should recognize that these are both divisible by 9 or 5. Either one works. I'm going to go with 9 first. So it gives me 5 over 80. And now I recognize they're divisible by 5. So that reduces to 1 over 16. So this is an area scale that shows us the comparison of the principal's photo versus the original, which means the scale factor is going to be 1 to, root this, 1 to 4. So what are the dimensions of the photo? His photo is going to be 4 times bigger than ours. So if we multiply each side by 4, his photo is going to be 4 times 4. That's going to be 16 inches by 5 times 4, 20 inches. And that is his scale. That is his dimension. Okay? All right. So we're going to explore more of these relationships between the area, the perimeter, and about the similar shapes. So what are we going to do? First, we're going to look at these. These are similar shapes, right? For each pair of shapes, calculate the area and perimeters and fill in the table. So the ratio of the sides, you can pick the corresponding sides. See how there's a 6 here and there's not a 6 here, so you can't do anything with that. Or there's no number here. So compare the 15 and the 25. So ratio of the sides, if you just look at that, is 15 to 25. And remember what I said, reduce when you can. It's really 3 to 5. All right. So what does that mean? Well, if the small figure's perimeter is going to be 6 plus 6 plus 15 plus 15. So that's 6 plus 6, that's 12. 15 plus 15 is 30. 12 plus 30 is 42. So small figure is going to be 42. Perimeter is a linear comparison. We're just comparing the length around the whole thing, which means we can use this ratio to help us figure out the large one, even if we don't know what that is. Another way to go is to just go ahead and figure out the missing side as well. So it's really up to you. I think we should figure out the missing side because we're going to have to use that for area later. All right, so let's go ahead and find the side. I'm going to call this y. Been using x's too much. So 6 over y equals 15 over 25. Comparing the 6 and the y, 15 and the 25. All right, you can reduce this down because I think it's a lot easier to work with it if it reduces down. So now if you cross multiply, or you simply look at this and say 3 times 2 to get 6, so 5 times 2 to get y, so y is 10. All right, so now if you want, you can just add them up. 10 plus 10, 25 plus 25. Well, 25 plus 25 is 50, plus 10 plus 10, that gives me 70. All right, now let's compare. Ratio of the perimeter, 42 to 70. If you reduce it out, you can reduce by 6. If you reduce by 6, oh no, sorry, you reduce by 7. If you reduce this by 7, you will get 6 over 10. Reduce more, 3 over 5. See how the ratio of the sides and the ratio of the perimeter are exactly the same? All right, what about area? Well, we now like to take a look at the small one. Base times height, 6 times 15. Use this as your work area to figure that out. 6 times 15, that will give us a good 90. Small one is 90 square units. And then the big one is 25 times 10, so that's 250 square units. Comparing the ratio, 90 over 250. If you reduce out the zeros, you get 9 over 25. Compare, isn't that 3 squared to 5 squared? Right? What we knew before still works. Okay? All right. Now, it doesn't just work on rectangles, it works on all the other shapes too. So let's review our beautiful 30, 60, 90 triangle. How do we know this is 30, 60, 90? We have 60, 90, so this missing one must be 30. Same thing, 60, 90. This one must be 30. So you kind of have to tilt it around to figure it out. All right. Now, before we even move on, you should at least fill out the missing sides of the triangle because you do know how. So if the shortest side is 6, then the hypotenuse is double that. That gives us 12. Then this leg is going to be 6 root 3. Okay. This triangle is a little bit harder to see because the hypotenuse is 4. That means then if you half that, you'll get the short side. So short side is 2, and then this leg is 2 root 3. Okay, so I can pick any sides to compare the ratios. So up to you. I am going to compare the smallest side to the smallest side. So small figure to large figure is 1 to 3. Double check. 4 times 3 to get that. 2 root 3 times 3 to get that. Beautiful. All right, what is the perimeter of a small figure? That is 6, 2 plus 4 plus 2 root 3. So it's 6 plus 2 root 3. Don't use calculator. Do not round this out. Leave it as 2 root 3. It's going to work out really nicely soon. Okay, same thing with the large triangle. You have 12 plus 16, 12 plus 6, that's 18 plus 6 root 3. So 18 plus 6 root 3. How do you compare the ratio of the perimeter? Well, let's use this work area again. You're comparing 6 plus 2 root 3 to 18 plus 6 root 3, right? At first glance, that looks really hard to compare. So what you should do is factor out what is common. Take a look at the top. They have 2 in common. So we factor out 2, you get 3 plus root 3. Same thing on the bottom here. You only look at the numbers outside. They have 6 in common. So that gives me 3 plus root 3. Now you should see these are the same. So this essentially is 1. So it reduces out. So you're really comparing 2 to 6, which again gives us 1 to 3. All right. All right. Let's compare area. Area for a triangle is 1/2 base times height. So area of the small triangle is 1/2. The base is the 2. Height is going to be our 2 root 3. So this reduces out, giving me just 2 root 3 for the small triangle. Area for the large triangle is going to be 1/2 base times height. So this makes this 3. 3 times 6 is 18. 18 root 3. So 2 root 3 over 18 root 3. Same as before, the root 3's will reduce out nicely for us. And you reduce 2 over 18 to be 1 over 9. Now let's compare. Ratio of the sides, ratio of the perimeter, the same. If we square both factors, we get 1 over 9, right? Same as what we knew before. All right. Last but not least, let's take a quick look at this picture. Well, I would personally figure out all the missing sides first. This is a trapezoid, so I will need the bases and I will need the height. So let's do the simple ones first. 5, 5, and 5. So that means this, and this should be the same. Well, since this is 40, this has to be 40, this has to be 40. All right. Now, 5 times what to get 40? 5 times 8. So that means this trapezoid is 8 times bigger. So if I take 8 times 13, I would get this base to be 104. Now, I'm going to take a quick look at this picture. This is an isosceles trapezoid because the two sides are the same, which means if I draw this line down, these two legs are going to be the same. So let's use a little math here. If this is 13 minus 5, you get 8. So that means this is 5, right? But then now you have 8 to give both sides, which means this is 4 and this is 4. Why is that important? If we cover this up, this is going to be a right triangle for us. And Pythagorean theorem, even though the picture doesn't look like it, but Pythagorean theorem says 3, 4, 5. So that tells me the height is 3. Okay? So using that same logic, since the big one is 8 times bigger, 8 times 3 gives me 24. Okay, now I have all the sides. I can go ahead and figure out the rest of the problems. So pick a side. We already kind of answered this, but pick a side. I'm going to pick a 5 compared to 40. 5 to 40, which gives me 1 to 8. So this trapezoid is 8 times bigger. Okay, now I'm going to erase the 4s so that doesn't confuse us when we're figuring out the perimeter. So perimeter of a small figure, you go 5 plus 5 plus 13 plus 5. So it's 15 plus 13, that gives me 28. Perimeter big one, 40, 40, 40, that's 120 plus 104, 224. Okay, so 28 to 224. Again, if you don't believe me, you can check. Just take 224 divided by 28. You will get 8. 1 over 8. Okay. All right. What about the area? Well, trapezoid, formula for trapezoid is 1/2 base 1 plus base 2 times the height. So that's a small trapezoid right now. So 1/2 times 18 times 3. Half of 18 is 9. 9 times 3. That would give me 27. Large trapezoid has the same formula. 1/2 base 1 plus base 2 times the height, 24. So let's see, that's 1/2 times 144 times 24. Well, you can half of whatever you want, but I'm going to half this one first. So half of this is 72 times 24. That gives me 1,728. So 27 to 1,728. If you, again, you can use your calculator to help you. If you divide it, you would actually get 1 over 64. And we know that because 1/8 should be the same as 1/8 here. If you square both factors, you get 1 over 64. Okay? All right. So now let's continue using our ratios. Well, Jessie examines the two figures at the right. She wonders if they are similar. Justify your conclusion. Well, let's look at the side first. The size scale factor is 7 to 21. So the scale factor is 7 to 21, which reduces out to 1 to 3. Okay? What about the area? Well, the area is 40 to 360. Okay, if we reduce this out, we get 4 to 36. That's 1 over 9. So this is match. 1/3 for the scale. If you square both, you get 1/9. So far, we know that the size and area match, but there's one problem. Even though the scale and area match, we still cannot conclude that it is exactly similar because the angles have to be exactly the same for us to conclude that. So even if the scale factor and the areas match, you still need congruent angles for similar shapes. So, sorry, it could be a little bit off and it's not similar. Okay? All right. Last one. Your teacher enlarged the figure on the right, so the area of the similar shape is 900 square centimeters. So I enlarged it. The bigger one has an area of 900. The original is 100. What is the perimeter of the enlarged figure? Well, we know that the perimeter has the same ratio as the scale factor. So if I just compare my area and square root my factors, then I will know the scale factor of my perimeter. So let's try that again. So I have the small to large. All right, for the area of the small is 100 to 900. That reduces to 1 over 9. This is for the area. So that means if I want just the scale, I need the number before we squared it, which is 1 to 3. All right, so for perimeter, small to large, the ratio should still be 1 to 3. It should be the same as the scale. So let's look at the perimeter of the small one here. If you take 8 plus 4 plus 5 plus 10 plus 13 plus 4, add them all up, you should get 44. So the large one, I don't know what that is. So again, cross multiply. The perimeter of the large one should be 132 centimeters. So that is the perimeter of the enlarged figure. Okay, all right, that's it for today.